The last examples I'm going to show you are decay models, and these are actually very similar to exponential growth models. If you recall, when we had exponential growth, it was y equals a and then 1 plus that percent change r to the t power. Now, when a real-life quantity decreases, and the key word here is it decreases by a fixed percent each year or other time period, the amount y of the quantity after t years is almost the same. You still start with your initial amount a, and instead of 1 plus r, we're taking away that percent from 1 to make it decrease. 1 minus r to the t power. Now that should make sense because remember, for decay, remember this base is supposed to be between 0 and 1. And so by subtracting that rate, you're guaranteeing that your base will be a number that's between 0 and 1, thus making it decay. So remember, a is the initial amount. I'm just going to write initial amount like that. R is the percent decrease as a decimal. Of course, right? We never put in just straight percents into our formulas. And the quantity 1 minus r is called the decay factor. Whereas, remember, in growth, 1 plus r was called the growth factor. This example that I'm going to do for you actually has to do with a car that I bought when I first started teaching that was worth $37,000 new. It was determined that the car's value decreased by 4% a year, and we want to find out what is the car worth after 5 years. My hint to you is let's first write a model for the car's worth after t years. Now, just to kind of back up, a lot of students don't realize that when you purchase a car, as soon as you make that final signature and you've paid for that car, even though you may not even have driven it off the lot, and everything is paid for, that car's value just decreased. Almost all cars decrease in value over time. There's only a few cars that actually increase in value. It's one of the things I would like to convince my wife of. Let me buy a nice car that would actually be one of those things that increases in value over time, and that would be a nice investment. But we don't have anywhere to put it right now. So maybe one day that'll happen. Anyway, we're going to use the formula y equals a, then 1 minus r to the t power. Now, remember, the key word to know that we're going to do 1 minus r is that it's decreasing in value. So we know the initial amount is $37,000, so I'm going to put in 37,000 here, and it's going to be 1 minus the percent. Now r as a decimal, remember r is 4%, right? But that's not a decimal. As a decimal, that'd be 0.04. So we're going to use 0.04 for r. So I'm going to do 1 minus 0.04 to the t power. This is our formula. And actually, let's write it one more step. So it doesn't look quite as ugly. 1 minus 0.04 is the same as 0.96. Now there you go. Isn't that number, that base, 0.96, is between 0 and 1, and that's going to guarantee that this is decaying over time. We're getting smaller over time. To answer the question, our t value is after 5 years. How much is the car worth, right? So we're just going to substitute in 5 and get 37,000 times 0.96 raised to the 5th power. And if you put that into your calculators, and you can go ahead and do that with me now, 37,000 and then 0.96, raise that to the 5th, to the nearest penny, the car's value has gone down to only $30,168.79 if we were going to be that picky about going to the nearest penny. So the car's value has decreased roughly, $7,000. What I'd like you guys to try now for your self-quiz is a couple of graphs, one that doesn't have any shifting, and then another, part B, which does have shifting. Oops. And the last question, C, is one of those exponential decay models. So good luck, and we'll see you tomorrow.